want to turn the presentation over to our conservator, Rachel Wetzel, who's going to talk to you about preserving the legacy of Robert Cornelius and other daguerreotypes in the Prints and Photographs Division here at the Library of Congress. Rachel, thank you.
Hello, everybody. Good morning. As part of Preservation Week, I would like to present on some of the initiatives taken here at the Library of Congress to stabilize and preserve our daguerreotypes in the Prints and Photographs Division. This presentation will focus on the invention of the daguerreotype, its development for use for portraiture in America, and the early work of pioneering daguerreotypist Robert Cornelius. It will illustrate how a multi-year conservation research project on Cornelius led to a new acquisition at the library and a concerted effort to preserve our daguerreotypes while increasing digital access to our large collection. This project began in 2015 for me with the examination of these two daguerreotypes made by Robert Cornelius in May of 1840 and December of 1839, respectively. While I was working at the Conservation Center for Art and Historic Artifacts in Philadelphia, Anne Downey, the paper conservator at the American Philosophical Society, brought these two daguerreotypes for examination and treatment. She thought that their hazy appearance had increased over the last decade. I knew that these two objects were amongst the earliest extant daguerreotypes made in America, which meant that there was more research needed to understand these materials before proceeding with any potential conservation interventions. For context, I will provide some background on the development of photography. Announced in France in 1839, the daguerreotype, named after its inventor, Louis-Jacques Daguerre, was the first commercially successful photographic process in the world. There is a much longer story of the history of photography that includes Nicephore Niepce, seen in the upper left, and William Henry Fox Talbot, who made a paper process. But for time's sake, I will just discuss the daguerreotype here. The daguerreotype is a photographic image that is produced in a very thin silver layer of a silver-coated copper plate. This diagram illustrates how it's made. So here's the silver-coated copper plate, and you would clip the corners and you would clean the daguerreotype with washing it with nitric acid, and you would buff and polish this plate until it was a completely shiny mirror. And then you would expose the plate to the fumes of iodine to make the plate light sensitive. From this point, that sensitized plate is placed inside the camera and exposed to light to form the image. Now this image is laterally reversed, which means it's the mirror image of what gets recorded. And it's also what we call a latent image at this point, which means it's not visible to the naked eye. The image becomes visible when you develop it under the fumes of mercury, which interact with the exposed silver to form the image on the daguerreotype plate. The next step is to put it in a bath of sodium thiosulfate, which is commonly called fixer or hypo, and this was used to stop the chemical reaction and make the image permanent. And then this step here is the step which we call gilding, which is using a heated solution of gold chloride that's poured over the daguerreotype plate to make the image more stable and increase the contrast. This step was not part of Daguerre's original formula, but was rather an additional step introduced later to improve the process. Its inventor, Hippolyte Fizeau, introduced gilding in August of 1840, which was about 1 year after Daguerre announced his process. But this actual step didn't become widespread or in common use until 1842. And then the last image is showing the daguerreotype in a housing. The daguerreotype housing provided an aesthetically pleasing way to present these handheld objects, but more importantly, it was essential to keep the plate from tarnishing. Generally, there are two types of styles. The one on the left, which is called the French Passepartout II, which sometimes has a reverse painted glass mat on it. This was the more common in Europe and what Daguerre used in his plates in France. And on the right is what we call a Morocco case, a leather Morocco case. And this was repurposed from the portrait miniatures, and it was the dominant style of housing used in America. Inside of that leather case is what we call the Daguerreotype plate package. And this generally includes the Daguerreotype, a brass mat, and a piece of glass. And those three layers were sandwiched together and perimeter sealed with a paper tape and a water-soluble adhesive. This piece here is called the brass preserver, and this was introduced around 1850. And it was a decorative way to cover up that paper tape seal. Daguerre's invention was shown on January 9th, 1839, before the French Academy of Sciences, which immediately fascinated scientists and artists around the globe. In agreement for a salary from the French government, Daguerre made public the formula for making these daguerreotypes on August 19th, 1839. While this was the most incredible discovery, it did have some limitations for use because the exposure times were incredibly long. Iodine made the silver plate light sensitive, but that sensitivity was weak. Hence, you had to expose the plate for a long period of time, upwards to 20 minutes. And for that reason, all of Daguerre's images were of landscapes or static objects. However, you can see here that this plate shows every little detail of the houses and trees that were captured in a very fine focus on this daguerreotype plate. This image by Daguerre, taken in 1839, looking over the streets of Paris, is a perfect plate to demonstrate the effects of long exposure times. You will notice that there is a faint shadow image of a man receiving a shoe shine, but no one else in the street. This wasn't taken at a time when all of Paris was sleeping. It was captured during the peak hours of sun between 10 a.m. and 2 p.m. Since the exposure was so long, anyone or anything in motion, either walking or riding in a horse carriage, would not be recorded in the plate. Only the men standing quasi-still for most of the exposure were captured in this image. For this reason, portraiture was considered to be unattainable with this process. Nevertheless, when the formula for the daguerreotype made its way to America, the scientific men in New York and Philadelphia set their sights on solving this problem. Robert Cornelius was one of the first to successfully take a photographic portrait with the daguerreotype, standing in front of his camera perfectly still for around 10 minutes. This image is currently the oldest extant photographic portrait in the world, taken in October or November of 1839, and it's part of the treasures collection here at the library. Obtaining a portrait with a long exposure was difficult, but there were several ways that other experimenters got around this. Some did so by increasing the amount of light. Some did by improvising their camera lens or improving the focal length of it. Others added greater sensitivity to the daguerreotype plate, or they used a combination of these three. For example, John William Draper and Samuel Morris dusted their sitters' faces with white powder and worked on a rooftop to increase the amount of light beaming on their sitters. And the team of Alexander Wolcott and John Johnson, along with Henry Fitz, invented a camera that utilized a ground glass curved mirror instead of a lens, which helped them to reduce exposure times. Still, sitting for these early portraits was described as being painful, causing tears to run down people's faces, or people having to keep their eyes closed the whole time, as seen here in some of these few other early extant portraits that were made in the months following Cornelius' self-portrait. Cornelius partnered with Dr. Paul Beck Goddard who discovered that bromine would increase the light sensitivity of the daguerreotype plate. Bromine was a relatively new compound at the time, discovered in 1826, and it was said that the two men bought up all the possible bromine so that no one else could try it. By double sensitizing their plates with both iodine and bromine, they decreased the sitting time, making portraiture possible. The two men kept this discovery a secret until 1842. Robert Cornelius went on to open up the first photographic portrait studio in Philadelphia in May of 1840, just 2 months after Wolcott and Johnson opened the world's first studio in New York City in March. Both studios utilized this lighting system that bounced the sunlight from the outdoors into the studio through a series of mirrors. A sheet of blue or purple glass was used to diffuse the large amount of light beaming on the sitter's face. You can see on the Cornelius image to the right that this technique produced a strong overall, even lighting on the sitter's face, which cast a shadow beneath her nose. Many newspaper accounts of Cornelius's studio describe this lighting apparatus, and recollections of the early days of daguerreotype indicate that Cornelius saw this setup in Wolcott and Johnson's studio in New York. Though little is known about this New York business, which likely operated through 1841, at which point Wolcott and Johnson focused their efforts on developing studios in the UK. Cornelius's time as a daguerreotypist was also brief, as he closed the doors to his business in March of 1843 to shift his focus back to his family's gas lamp business. To this date, not a single daguerreotype made in the Wolcott and Johnson studio in New York has been positively identified, despite accounts of hundreds of portraits having been taken there. Just last fall, this portrait of Henry Fitz Jr. was found in a descendant's home, and it went to auction. This plate is now owned by the Nelson Atkins Museum in Kansas City, Missouri, and this may have been taken in the Wolcott and Johnson studio in early 1840, but research on this is still ongoing. Conversely, several dozen Cornelius plates have survived, which make him a perfect subject to study and understand the early American photography. His work progressed through all of the major changes made to the daguerreotype process, which occurred primarily in the first 3 years of its existence. It's hard to compare his work with his contemporaries, as so little, if any, of their work has survived. This makes studying the formative years of photography quite subjective. I reached out to my colleague, Adrian Lundgren, and together we assembled a team of experts to begin studying Robert Cornelius's work. In my opinion, research efforts with a diverse group of professionals are more successful at discovering new information because we all bring a different perspective and a different way of looking at photography. This team included curators Beverly Brannon, William Stapp, and Sarah Weatherwax, conservators Adrian Lundgren, Andrew Robb, and Paul Messier, scientist Edmund Chesney, and a modern-day daguerreotypist Mike Robinson. While working at a nonprofit institution at the time, I was able to apply for a research and development grant from the National Endowment for the Humanities. With this funding, my goal was to locate, examine, and uniformly photograph as many Cornelius daguerreotypes as I could find and create a publicly accessible database that would share all of this information that I gathered. This database included information about the physical attributes of each daguerreotype, its housing, its provenance, any history of treatment or analysis, its exhibition history, and uniform photography of each plate. This was designed based on the attributes that each team member was interested in learning. The final product from the NEH grant is now part of the permanent collection at the Library of Congress. And I'm happy to report that when I began, the known number of Cornelius plates was 30, and by the end of the project, I had increased that number to 54. This may not seem like a lot of images to you, but in the context of this time period of the first 3 years of photography, Where most of these daguerreotypes that were made no longer exist, this is a large amount of daguerreotype plates. So the following will be a brief discussion on the findings from my NEH project. On May 6, 1840, John McAllister Jr., seen at the bottom left, was the first to sit for Robert Cornelius in his portrait studio located at 8th and Lodge Alley in Philadelphia. For the next few months, Cornelius was inundated with customers wanting to have their daguerreotype made. Because he was a metal worker by trade, he housed his images initially in these stamped metal frames that he produced in his family's factory. You can see the variety of styles that he used here on the left. These are probably too time-consuming to produce once his business really took off, so Cornelius began housing his daguerreotypes in leather cases by June of 1840. He sold the portraits that were in the metal frames for $6 and the ones in the leather cases for $5. These cases that he used all had this acorn pattern stamped into the leather. The case lids were lined with a simple green or purple silk, and a green or purple velvet pinch pad was placed around the daguerreotype in the case tray. Again, using his metalworking skills, Cornelius produced his brass mats and conveniently stamped them with the R. Cornelius and the abbreviated Philadelphia along the bottom edge. This particular leather case has been called the quote Cornelius case, and thus false attributions to his work have been made to other daguerreotypes housed in these same cases. Through my research, I was able to identify the maker of these cases as Henry Habermehl, who had a shop a few blocks from Cornelius's studio and was a maker of Morocco cases for medical and dental tools. He sold these cases to other daguerreotypists in Philadelphia and to some of Cornelius's students who all worked as itinerant photographers in other locations. All of Cornelius's plates were made on rolled clad plate stock that Cornelius worked to a smooth finish with a particular polishing compound. A true perfectionist, Cornelius cut each plate precisely to the standard 6-plate size, never clipping any of the corners. In examining his plates, I found that he didn't perimeter seal the plate package with the tape. Instead, he glued a whole sheet of paper onto the verso of the plate, which wrapped around to the sides of the glass. You can see the corresponding adhesive stain on the verso of the daguerreotype plate, where the adhesive caused copper corrosion and tarnish. In the absence of the original paper seal, evidence of this glue stain was seen on every single Cornelius plate that I examined. In this case, the written information about the date and time of this portrait was made on and recorded on this paper tape seal. Here is an image of all 54 Cornelius daguerreotypes I examined and added into my database. It shows the progression of his work over 3 years that he operated his studio. I almost doubled the known amount of plates from 1982 that were exhibited in the only exhibition of Cornelius's work at the National Portrait Gallery, which is curated by William Stapp. I cannot help but praise Will for locating 30 of these plates in an era before the internet existed. I feel like my job was much easier in that aspect. In this exhibition in 1982 at the National Portrait Gallery, it was a very innovative exhibition, not only because it featured a singular daguerreotype artist, but it also had a scientific analysis component to it that investigated the development of the daguerreotype in America through Cornelius's work. 15 of the 30 plates that were exhibited were analyzed by Susan Barker using scanning electron microscopy with energy dispersive X-ray analysis, which is a big mouthful, and from now on I will just refer to as SEM-EDX. Barger examined the silver image plate morphology, similar to this image seen here on the right. And it was she was able to determine if the daguerreotype was sensitized with iodine or iodine and bromine, if it was gilded or ungilded, and if the plate had been cleaned with potassium cyanide or thiourea, two materials used historically to reduce tarnish on daguerreotypes. I will further explore all of these concepts within the presentation. Exposing the silver layer of the daguerreotype plate to a halogen, such as iodine or bromine, is what makes the plate light sensitive. Daguerre's formula used only iodine, which worked but was very slow. To reduce the exposure time, one needed either a faster halogen like bromine in conjunction with iodine to increase the sensitivity of the plate to light. Bromine used on its own caused fogging of the plate, so it was determined that a combination of the two halogens resulted in the best exposures. Visually, the sensitization of the plate cannot be distinguished with the naked eye, as seen here with the plate on the left, which is single sensitized, and the one on the right, which is double sensitized. These were both analyzed by Susan Barker in 1982. The only way to really determine this is to look at the image morphology through the scanning electron microscope. The use of gold chloride to gild the plate provided a visual impact and added stability and contrast to the image particles. You can see the difference in the ones on the left that are ungilded versus the ones on the right, which were gilded. However, it's easy to see this in this lineup array like this, but looking at an individual daguerreotype on its own, it's not, you're unable to confirm or deny the presence of gold without the actual positive identification from scientific analysis using an analytical technique called X-ray fluorescence spectroscopy, or XRF. The silver mercury image of the ungilded plate is generally less bound and less stable than its gold counterpart. Thus, the surface of an ungilded plate can easily be wiped off with a touch of a finger or a brush. Gilded plates are more robust, but they are still subject to scratches and abrasions from physical contact. So bare plate daguerreotypes should never be handled without gloves, and you should avoid all direct contact with the image surface. Since daguerreotypes were typically sealed with paper tape around the perimeter to avoid tarnishing, an inherent microclimate formed within the plate package. While this was meant to protect the silver, it also created the perfect environment for the glass, brass mat, and the silver of the plate to interact together, which caused glass corrosion. 19th century glass was made with fluxes such as silica and alumina. And when the glass degrades, these byproducts weep out of the substrate, causing this haziness you see here over the plates. Sometimes those sticky materials can drop onto the surface of the daguerreotype and mar it permanently. The idea of putting these daguerreotypes in a sealed package was not just an aesthetic decision, but it was one to protect it from tarnishing, which was a known problem from its inception. Beginning in the 1850s, recipes for cleaning the daguerreotype with potassium cyanide began to be published. Washing daguerreotypes has a long and sordid history. Potassium cyanide is a deadly substance that will remove heavy tarnish on a plate, but later, as the daguerreotype ages, will induce further tarnishing, as seen in this daguerreotype here. This substance was casually used by the general public and photograph historians to clean daguerreotypes well into the 20th century. In the 1950s, cyanide was replaced with thiourea, an acidic cleaner that contains sulfur that was used as a, quote, silver dip, similar to jewelry cleaner. This material will thoroughly clean a plate, but later causes brown spots that appear on the plate, which are commonly called Daguerrean measles. And I think you can see those in the specular image on the right and the corresponding UVC image in the middle. This aggressive cleaner will also cause fogging of the plates, as it can be seen here on this image of Dr. Goddard that was cleaned in 1978 with thiourea. And this white part around here is the fogging. Conservation and scientific studies have shown the irreversible effects of this cleaner, and conservators even put a moratorium on its use in early 1980. Still, many daguerreotypes are being cleaned with this harmful substance today. The results of both potassium cyanide and thiourea are deceiving in that they result in shiny, pristine-looking daguerreotypes after the washing. However, their damaging effects were seen months or years later as the daguerreotypes age. In my opinion, these materials should never be used to clean daguerreotypes, not even in highly diluted solutions or even for brief immersion times. On the other hand, things that age naturally without intervention can sometimes be problematic. This daguerreotype made in 1840 has never been opened before, and you can see that there is a lot of debris and material that obscures this image. A look under the microscope shows dust, glass weeping products, green copper corrosion from the glass weeping that fell onto the plate and degraded through the silver, and this orange colored debris on the surface. The amber debris is sometimes on the plate, and this might be a little hard to see. In a case like right here, this one is actually on the plate, but these ones are still stuck in the glass. As you can see, there's a corresponding shadow beneath them. But a closer magnification shows that these are actually book lice that are trapped in the sticky glass corrosion products. And some of them have fallen onto the surface of the daguerreotype, which may have marred the surface permanently, particularly in this case of this ungilded daguerreotype. Which brings us here to the Robert Cornelius self-portrait. I want you to take a moment and look at these two versions of this daguerreotype. The one on the left was a reproduced image of this plate in 1891 when the daguerreotype was approximately 50 years old. And the one on the right is how it looks today, nearing 175 years. Glass corrosion is certainly present, but what is most alarming is the amount of tarnish that is formed around the perimeter. If this is left for another 100 years, will we even have any of this left? This is another example of natural aging that has not been beneficial to the object. Conservation is a young field, and we don't have all of the answers of what to do with ungilded daguerreotypes, especially rare experimental ungilded daguerreotypes such as this. But with all of my efforts to understand this man's work and learn about early American daguerreotypes, I feel I can no longer benignly neglect this precious piece of history. I am working on a preservation rehousing effort to properly preserve this image and with minimal intervention, and hopes to stabilize it as it exists today and keep it around for future generations. And I won't lie, the thought of having to just even handle the world's oldest extant photographic portrait keeps me up at night. Based on my study of Cornelius, curator Micah Messenheimer and I started an initiative not only to improve the preservation state of our large daguerreotype collection, but increase access digitally to the collection for online researchers at the library. This effort includes the examination and assessment of approximately 800 daguerreotypes. Written and photographic documentation will be conducted on each plate. The 19th century glass will be replaced with a more stable, inert borosilicate glass, and plates will be resealed in a non-invasive manner. Finally, new custom storage boxes will be made for each plate. Since we have the opportunity to examine each daguerreotype intimately, this gives us the opportunity for a digital humanities initiative where we can update information in our catalog records that includes images of the cases, bare plates, and other identifying details that would be useful for researchers to understand how these daguerreotypes were made. Before I talk about the details of the survey, I want to mention that every component of the original daguerreotype is critical to the history and provenance of the object. How the daguerreotype was sealed is important. How the photographer placed it in its housing and which materials were used tells a part of the story. So retention of all the original materials is crucial. Information gets lost when components of the daguerreotype plate package are removed or cases are swapped out for other cases or frames, like this one on the left. The original case that Cornelius used was either lost or somebody put another daguerreotype in it, which could lead to a false attribution. Remember the unusual type of seal that I told you Cornelius used? Well, of all of the plates in my database, only 4 have these original paper seals. Again, we may have lost valuable information about the dates and times that these images were made. And the portrait of Dr. Goddard, which was made in 1839, just after the self-portrait, currently has a typed note on the back that states that the original seal with a handwritten note was dissolved in the cleaning of this daguerreotype. While it is nice that the information was transposed to a new backing, the original handwritten label would have provided a more firm attribution of the date of this image. And remember the daguerreotype I mentioned earlier of the man getting the shoe shine? That daguerreotype was catastrophically lost to a failed cleaning attempt. I keep all of this in mind when I'm intervening with our daguerreotype collection here at the library, and I vow to leave a minimal footprint of what I've done. So to start the daguerreotype survey, each plate is uniformly photographed before it's examined to show the case, daguerreotype package, and bare plate. This gives us a record of what the image looked like at the present moment. Some of our daguerreotypes in the collection remain as they were made originally. Others have been intervened before we acquired them, and some have been treated in the past in our conservation lab. We have records of these latter conservation treatments that we can use for reference, but in the other scenarios, it's unclear what the history of the object is. So we are documenting what we know now about the daguerreotype to preserve any history before we open the plate packages. Each plate, case and mat, and preserver is examined and notes are added into fields with an internal database that Micah and I share. Like this information I collected for the Cornelius project, every attribute is recorded into the database along with current and past treatment and exhibition history. All of this information is also recorded onto a paper document in case the digital database is lost. I cannot stress enough the importance of redundancy and analog copies for projects like this. I'm using sources like Fixed in Time, Craig's Daguerrean Registry, and the book called Daguerreotype Hallmarks to identify the time and place of where these housing materials were made so that we can narrow down the focus of undated or loosely dated photographs in the collection. All of this information will be used to update sections of our catalog record. For the treatment portion, the original glass is removed and retained without being cleaned in case future research on glass corrosion is necessary. The P&P accession number is written in the upper right corner of the recto of the glass to retain its positioning and keep a record of which daguerreotype it was removed. If the original seal is intact, they are left adhered on the verso of the plate to show evidence of how they were assembled. In some cases, the seals need to be trimmed a little on the sides to accommodate the new package, but the bulk of the seal is still visible on the verso of the plate. The bare plate daguerreotype is examined for hallmarks and other identifiers, such as how the corners were made, whether they were squared off like Cornelius, clipped, bent upwards, etc. And sometimes the daguerreotype is crimped the edges of their plates, like the one seen here in the center. Evidence of tarnish and previous cleaning are then recorded, as well as notes on general condition of the plate and any addition of hand coloring. In some cases, the use of XRF spectrometer is used to determine if gold is present or not while we have access to the bare plate. XRF is a non-contact, non-destructive scientific testing technique that uses an X-ray beam to detect particular elements in the daguerreotype plate. If gold is present, it will present as a peak as a specific energy value on the spectrum. Because this step requires extra handling of the object, we are only using this technique on daguerreotypes we believe to be ungilded. This will help us positively identify them for the future, as these objects will have special treatment and storage considerations. The daguerreotype receives a new sheet of inert borosilicate glass and is resealed with an acrylic pressure-sensitive tape over a sheet of inert polyester, or trade name called mylar, that's placed on the verso. This ensures that the tape does not come into direct contact with the daguerreotype plate at all. Pressure-sensitive adhesives tend to be generally problematic as they age, but are useful for their strong adhesion. For this project, I chose to use Filmoplast P90+ because it passed the photographic activities test. However, this tape has received a temporary designation on the Audi test, meaning it's only recommended for use for 6 months. No pressure-sensitive tape is perfect, so we choose the one that we know will interact the least with the silver in a negative manner, but also modify it to assure that it has no contact with the actual daguerreotype plate. Other pressure-sensitive tapes are not recommended due to their poor aging properties, yellowing of the carriers, and cross-linking of the plasticizers in the adhesive. New custom-made boxes are being constructed for each plate that includes a small velar recess to hold the original glass that's been removed. All of these materials used to construct the box and those that are placed inside of the box have passed the photographic activities test and won't interact with the daguerreotype. Keeping all of the original materials with the object is essential for retaining its full history. Every daguerreotype is photographed again after the glass is replaced and the plate was resealed to retain a record of the before and after condition. In some instances, the cases are repaired and those are also photographically documented. But you can see here what a huge improvement just changing the glass can make. Visually, it looks less distracting without all of those glass corrosion bubbles, but it's also safer and in the end to have only inert materials within the daguerreotype package. Washing daguerreotypes is not a part of this multi-year survey project, as I am currently investigating the effects of cleaning agents as part of this overarching project alongside Dr. Tana Villafana in the Preservation Research and Testing Division. We began examining a daguerreotype that had Daguerrean measles from a thiourea cleaning. And we looked at how those measles were still present under SEM after I rewashed the plate in ammonium hydroxide, despite the fact that they appeared to be gone visually when I viewed it with my naked eye. And this is the before treatment. So this is the tie line stain from the thiourea measle. And these are 2 sulfur stains. But you can see the tie line stain is still visible after treatment, but it's reduced. But it's these 2 sulfur stains that are still there that then will form new measles again as the daguerreotype ages, despite my efforts to clean it. For the present moment, we will also be taking a look at the surface morphology using SEM EDX of all 10 Robert Cornelius daguerreotype plates in the library's collection to better understand his working methods. This is a joint research project between 3 departments in the library: the Conservation Division, Preservation Research and Testing, and Prints and Photographs. We are hoping to confirm some valuable information about when Cornelius employed bromine and fill in some gaps in information from the analysis done in 1982 for the Robert Cornelius exhibition at the National Portrait Gallery. None of the plates that the library owns were analyzed in the 1980s, so there is much to learn from our collection. Which leads us to our latest Cornelius daguerreotype acquisition, which came into the library as part of a larger donation of materials that belonged to one of his direct descendants, Sarah Bodine. Ms. Bodine located me shortly after I arrived at the library in 2019, and I went to her home in February 2020, just before the pandemic hit, to meet her and see her collection. The greatest part of this project is that I have met 3 Cornelius descendants in person and 1 virtually, which provides a personal connection to me for this research. On my trip in February, I was joined by Robert Cornelius IV, who goes by Bob, who I had met in Philadelphia in 2017. I was able to introduce him to Sarah Bodine, connecting these 2 relatives for the first time. We had a really memorable day looking at all of Sarah's collection together and talking about their great-great-grandfather. And for me, this was the absolute highlight of the project. Included in Sarah's donation was a Cornelius daguerreotype, several other cased images of his children made by other Philadelphia photographers, 2 portrait miniatures of him, a handmade metal box containing many experimental camera lenses, boxes of personal ephemera, 7 patent submissions, and other materials pertaining to the Cornelius and Baker Gas Company. We are so thankful at the library to Sarah Bodine to receive such a significant donation of 165 items that belong to Robert Cornelius. These materials complement the existing collection of Cornelius plates and other Philadelphia daguerreotypes that were part of the Marion S. Carson collection donated in the 1990s. Ms. Bodine's materials are all being processed and will be available to researchers in the near future. They will also be featured in a book on Robert Cornelius that I am writing for the library, due out in the spring of 2024. In conclusion, I would just like to reiterate that daguerreotypes are one-of-a-kind, unique photographic objects. Since there is no negative involved, each plate represents a singular capture of a particular moment in time, sometime between 1839 and roughly 1860, when this process fell out of fashion. Daguerreotype portraiture, particularly in America, was extremely beloved, and many people took up the daguerreotype as a profession, including men, women, and people of color, which indicates that photography is a universal language. Some of the makers, like Cornelius, are well known, while others fade into obscurity. However, it is with these large connoisseurship projects that we learn something that makes one daguerreotypist unique that may help us to provide the missing links to discovering other contemporaries of the time. My project relied heavily on the consistent attributes seen on all of the Cornelius daguerreotypes, and it became abundantly clear when he did not make the portrait, as it did not meet his standard criteria of the work. When history is shuffled around by careless intervention, whether it's case swapping or catastrophic cleaning, we lose a bit of the link that tells the story of photography. While we can't erase the past, we can collectively move forward in a more thoughtful and sympathetic manner to ensure that these mirror-like memories of the past remain for future generations to enjoy. I hope the efforts made here at the Library of Congress inspire other initiatives to increase research access and the understanding of daguerreotypes, and maybe help solve some of the problems that have plagued the past in the preservation of daguerreotype images. I would specifically like to thank all of my colleagues and supervisors at the Library of Congress for continuing to support this project that I brought with me from my previous job. I also would like to acknowledge those folks in my past employer and the NEH who gave me the opportunity to discover this rich history of early American photography. I am particularly indebted to the family members of Cornelius, who so generously shared their personal family memorabilia and history with me, and to my mentor, Will Stapp, and my brilliant colleague, Adrian Lundgren, who have supported me fully since 2015. Thank you so much for listening. If you are more interested in learning more about this, I've been keeping a social media for a number of years now, so you can follow either of these links. And I'm happy to take any questions.
Thank you so much, Rachel. This was really amazing. So much interesting stuff in here. So we have a few questions starting to come through. I'm keeping track of the questions that are in the chat box, but if you have any questions coming up, please enter them into Q&A. It's just easier for me to read them off. Let's start, oh, just a second. Okay, let's start with a couple of the ones that came in through chat. Somebody would like to know if you kept the antique imprisoned book lice, because it's possible that the Museum of Natural History would love to examine them.
Oh, well, I actually haven't taken that daguerreotype apart yet. So I took those pictures through the microscope through the glass. So I get in contact with me. My email is rwet@loc.gov. So I think we can spare a bug or two.
Do you know of any of the individuals who used some of those toxic chemicals to clean daguerreotypes in the past? Did they ever develop any health problems?
Yeah, that I mean, people definitely can die from exposure to potassium cyanide. I don't know of anyone personally having health problems, but I mean, it's funny and also sad at the same time, but a lot of the, I've been collecting articles about cleaning daguerreotypes from the 1850s on, and there are some articles that talk about how to obtain potassium cyanide from your local pharmacy and how to, because they wouldn't just give it out to anybody at a certain point. And so it's like how to show them that you know what you're doing to obtain this deadly material. So I'm sure there were people that got sick from using it for sure.
Thank you. And do you know if the type of gloves you wear when touching the bare plates make any difference? They wanted to know specifically between the difference between latex versus cotton.
Okay, sure. We use nitrile gloves here, which are similar to latex gloves. We just don't use latex because people have allergies to it. But I personally only use those gloves when dealing with bare plate daguerreotypes, because the cotton gloves, I have very tiny hands and they're always too big for me. So I don't feel like I have any real tactile sensation. Not that you have much with a nitrile glove on your hand, but I feel like I can tell when I'm touching better with the thin glove versus a thick cotton glove. And also I would point out, there are some cotton gloves that have these little plastic nubs that I think are supposed to help with gripping. And I definitely would never recommend you to use those at all for photographs, because I've seen those little nubs imprint in even gelatin emulsions. So I would caution you not to use those.
I just saw a question come in. Can you go back in your presentation and post the slide that has the navigation pane outlining the characteristics you record when examining or cataloging the cased images?
The image of the database?
I think so.
This? Is there a question about it?
Yes. Yes, that's what they wanted.
Okay.
Okay. There were a couple of questions about storage conditions, and I know you talked about rehousing the daguerreotypes, but maybe you could talk about, environment as well.
Sure. I mean, daguerreotypes they're not as, I mean, they need a particular type of environment that is, ideally 70% Fahrenheit and 55% relative humidity. They can do a little better in slightly cooler, but they're not anything that you have to put into cold storage or anything like that. And actually, we never really recommend to put anything that has a glass component into cold storage. So yeah, I think that it's not as fussy as some other photographic processes.
Did you ever come across any broken plates, and what do you do conservation wise when you come across those?
I've never seen a broken daguerreotype plate in my entire time as a conservator. Broken amber types, yes. Broken daguerreotypes, no.
Okay. Somebody was wondering how geographically dispersed these Cornelius plates are, and is there a map of where these are located?
I did once make a map. There are in the United States, there are some in Canada. There is one that I actually don't have in my database, but I met the person and she lives in Austria. So they're generally in the United States, but there are some dispersed in other countries. And I would say most of them are on the East Coast.
Okay, thanks. Somebody wanted to know if Cornelius's collection was passed down through the family, or was it dispersed throughout various family members?
That's a good question. So, so Cornelius had 8 children, and 2 of the descendants I've met, Bob and Al, they both descend from his eldest son. And Sarah and Joanna, they descend from this, coincidentally, even though they've never met, they descend from the same daughter who was, I believe, the next to last youngest daughter. So Sarah's descendant, her name was Helen Cornelius Bodine. And when Cornelius passed, her husband, George Bodine, was the executor of his estate. So he helped sell off his estate called Lawndale in Philadelphia. So I'm assuming maybe that's why she ended up with a large amount of material. But Al and Bob both come from Robert Conley Cornelius, and they both have material, but different amounts of it. So I don't know how all of his belongings got distributed, but so far it seems like these 2 particular descendants have passed them down the line.
Thank you. Can you briefly explain again the intervening or layer between the tape and the plate itself? Oh, they just want to know what material you recommended for that kind of barrier.
I use inert polyester. The trade names are Mylar or Melanex, but it's just a clear, thin plastic that passes the photographic activities test.
Somebody would like to know if it's okay to rinse an image with distilled water, and also, do you ever use canned air?
I don't recommend anybody really washing or rinsing the daguerreotypes. So you just don't know what it is that you have or what's been done to it in the past. It's really risky, and I don't take washing lightly, even as a conservator. I rarely do it myself. And I have access to all these analytical tools and other things, before I would ever even consider doing something like that. So I definitely don't recommend rinsing daguerreotypes. And canned air, no, I don't use that either. I have just a hand air bulb that I use. I think you can actually see it right here.
It's a lot more gentle.
Yeah, yeah.
Oh, somebody has a question about the camera and lighting setup for these, which I imagine a lot of people would be interested in. Can you describe that a little?
Sure. Should I go? Let me just go back. So the camera, I don't know if it exists. I hope that somebody has it in their attic somewhere. But from what I've been told, his camera was made by a man named Joaquin Bishop, who worked at the University of Pennsylvania. And Joaquin Bishop also made a camera for Dr. Goddard, and that camera still exists and is at the Franklin Institute. So it's basically where you see here, the camera was it's just a wooden box basically that has a slide on it. So you can, the plate is on the back side, and then you move the slide back and forth to change the distance between the lens and the plate. And there's a little kind of peak hole at the top that you're, or in the focusing lens on the back, that you could see that your sitter is in focus, and then you put the plate in. But it's a pretty simple contraption, literally like a wooden box with a lens. And it's described a lot in his in the newspaper articles about his studio, but I've never actually seen his camera, and I don't know if it still exists.
I actually think Sarah might have meant your camera setup when you're
photographing
sorry. the daguerreotypes. No, that's okay. I mean, I love this diagram too.
Okay, my camera setup. So this was made by Mark Johnson, who's in Pittsburgh. It was especially designed. It's called a copy cube, and he made it for me when I was doing the NEH project. So it basically collapses down, and I can put it in a little box, and I take it on a million different plane rides with me. But it has a circular ring of lights in it that are LEDs, and then there's kind of a opaque white plastic that diffuses the light. So it gives you this overall even lighting scenario. So if I'm sure you've all tried to take a photograph of yourself in a mirror with your cell phone, and you get the image of your cell phone in it. So this is kind of photographing a daguerreotype is the same concept, since it's a mirror. So you often get the camera lens ring in it. So that this piece right here is coated on the other side with black velvet, so you don't ever see the ring of the camera in the daguerreotype plate. Hope that makes sense.
Yeah, thank you. It's such a cool contraption.
Yeah.
Right. Shoni was asking about later daguerreotypes that have been colored, and if so, is there a typical time period for those?
Well, I mean, they were done, hand coloring was done like more commonly in like the mid or the late 40s on. I mean, you could add coloring to most daguerreotypes, but not ungilded daguerreotypes, because I told you that if you touch the surface with a brush, you would remove the image. So you won't find any hand-colored ungilded daguerreotypes. But I think more like the latter half of the 40s, and definitely like things got a little more elaborate in the 1850s with, you know, hand coloring and you know, these elaborate brass mats and preservers. Things made in the 1840s tend to be more plain. Like if you look at this daguerreotype that's on the screen, this one's definitely an 1850s one. Like the case has all this elaborate gold tooling on it, and the velvet up here is embossed with a very distinct pattern, you know. So like things from the 1840s tend to be more basic looking and simple.
Thank you. I think we only have time for one more question, and I know that there are some we didn't get to. So before I pose this last question, I'm typing the link to our preservation reference services, and you can always ask us questions through there, not just about daguerreotypes, but about anything preservation related, and we will get an answer to you.
Yeah.
So this last question, do you have an opinion on the porosity of Filmoplast P90 versus the aluminum tape, which prevents air incursion?
Oh, boy.
I know, it's a tough one.
I don't really think about the porosity of it. Honestly, it's more about whether the tape passes the photographic activities test and that other tape does not. So, I mean, as you saw from the daguerreotype showed with the bugs in it, like even if you have a very good seal, you know, it creates this microclimate in there. So I don't know about the porosity. I mean, I think you'd want a minimal amount of airflow, not to completely shut it off. I think that Filmoplast does a pretty good job. Clearly that silver tape has a, I don't know what that membrane is, but it is more, it lets less things through, but it also is not a good quality tape. So I wouldn't recommend using that silver tape on daguerreotypes.
Thank you, Rachel. And just as a note, I did put information on the photographic activity test in the chat
Great.
box. That's a good resource for anybody to have. And most materials that have passed the PAT should be labeled with PAT or
Yes.
photographic activity tests. So when you're buying supplies, you should look for that. I think that was it for today.
Great.
So thank you all very much. And Rachel, this was really fantastic.
Thank you.
Hopefully we'll see you tomorrow.